We host and manage that kind of application and services, but notably critical application and services for healthcare companies and also for healthcare public services. We're based in Lille, mainly, in the north of France, and in Paris. I'm from Lille. About me, I like computers, storage, of course, beers a lot, barbecue, and photography. So that's a few topics we can talk about. All right, we're going to start by assuming you have a brand new Ceph cluster. Maybe you're starting with your first cluster, or maybe it's one of many's. Everything is else okay, you read the docs carefully, you went on the mailing list maybe to ask opinions on your design considerations. And so your SSDs are okay. If you're using SSDs, you are enterprise grade SSDs, or else you're going to have a real bad time, trust me. You have plenty of RAM in your OSD nodes that allows your cluster to breathe. And your network is okay too, MTU and whatnot. So what to do next? I'm going to talk about 4 major topics: logging and monitoring, tooling, updates, and general maintenance and cluster life. So let's start with logging and monitoring. These are the main Ceph services or components that you usually can find on the Ceph cluster. And there are a lot of them. So there can be tens, hundreds, or even thousands of components or services across tens or hundreds of nodes in your cluster. That's a lot. And all these components, they give you information in the form of logs, but it's scattered all across your cluster, all across your nodes. And what's the solution? The solution is to aggregate them. You want to aggregate the logs for one cluster, but maybe you want to aggregate the logs for multiple clusters in the same place. Because imagine you have logs about OSDs flapping on multiple clusters. Maybe if they share the same network infrastructure, you can say, hey, it's the network. So how to do so? For you that are not familiar with logging, the classic stack is the ELK stack. It's based on Elasticsearch, Logstash, and Kibana. Elasticsearch being the database, Logstash the log parser, and Kibana the interface, the GUI to create dashboards and console the logs. So if you already have a solution for logging, maybe use it. If you don't, really look into the ELK stack. It's really popular and it works really great. The other part is collecting the logs on your servers. So there are, thanks to open source, there are a lot of options. If you already use some, try to use the same one that you're familiar with. Other way, or you have other solutions, syslog, rsyslog, raylog, filebit, whatever. If you don't know them, try a couple and choose the best for you. Okay, Ceph can be really chatty, so you might want to focus on tuning the logging for your Ceph cluster because hundreds of daemons, stuff like that. Log levels go from 1 to 20, so you can have a lot of information on every transaction on your Ceph cluster, but most of the time you don't want that. For general purpose, log level 1 or 2 is enough. Also, you want to configure your global log options. Your global log options are send the log to syslog, send the log to files. If you send them to syslog, maybe you don't want to send them to files because it's duplicate. It's use lost space on your servers. And also, you may want to tune the syslog level that you send to your syslog. Info is the default, but maybe you want only warnings or error to have more precise information in your log aggregator. If you want to know more about setting up a Logstash, the ELK stack, there's a great talk from FOSDEM from 2 years ago by folks from SUSE. They go a bit deeper, how to configure Grelog, how to configure grok filters to parse the logs from your Ceph clusters. So it's very easy to find out with a basic Google search. So next up, monitoring. I want to make a bit of a difference between monitoring and metrics. Monitoring to me is how to get the state of your Ceph cluster in case there are errors or so on. And metrics is really collecting data in the form of metrics to analyze the performances, behavior, or really dig into something that troubled you in the cluster. So, when it comes to monitoring, use your tools. You should have, I hope you have a monitoring solution for your infrastructure. So focus on that and integrate Ceph in it, or the other way around, it depends on the solution. And really use your existing processes to get your teams on board, write the good procedures, to address any failure in the system that can be managed by your responding teams. Once again, open source, lots of solutions if you don't really have one. Zabbix is a popular one. It even has a module integrated in Ceph Manager that can directly send information to your Zabbix instance. Or you have Nagios and company, or so on. Many of them, most of the monitoring tools have Ceph modules. Okay, metrics. To me, metrics is a bit different. You want to use the right tool for you. And of course, use Grafana to console the metrics. What I mean here is maybe you already have a platform or a stack to collect metrics. But if you can build something better and for Ceph metrics and you don't mind, yeah, go for it. Because people that are going to console the metrics, they go there for a purpose. So they want the best tool to find the information the more easily and the more fast as possible, the fastest possible. Again, in the manager service, there are modules, Prometheus, InfluxDB, and Telegraph that can send metrics data directly to your metrics server. But they are great, but you have to take real care of the major and minor version you are using, because some modules are integrated only in the later versions of Ceph, and also you have to look into the statistics that they send to your metrics server, because everything might not be there. Yeah, you want to use the manager and the modules, but you don't have Luminous yet. Well, but please upgrade. GUI is end of life, and we'll come back to the topic of upgrades. If you don't have a metric stack, or even if you have one, you should look at the Ceph Metrics project. It's a really nice project by the community, which integrates collectd and Python modules to collect the data on your nodes, Prometheus to store them, and of course Grafana to consult and build dashboard. So there are built-in dashboards that give you a really good overview of your cluster, and they are really great. And of course, there are Ansible playbooks, so you can it can be a one-stop shop. You can go from scratch and deploy a whole stack if you need to. And of course, that's what we did. Everything is open, so you can handpick components to fit your needs. For us, we already had Grafana servers, so we didn't want to have another one. So we just handpicked the dashboards and a few of the collect the modules, and voila, we had our full metrics for Ceph. All right, next topic is tooling. Quick show of hands. Who here doesn't use a configuration management tools for operating the Ceph cluster? I'm talking Puppet, Ansible, even Ceph deploy. Yeah. Okay, not too crazy people. Yeah, good. So please use a management tool. Again, there are a lot of components. They throw a lot of logs at you, but you also need to configure them almost individually. So using a configuration management tool, it makes things easy, and also it centralizes the configuration in one place. So you can easily review it and update it. So using a configuration management tool is the way to go, but where do we go from there? Yeah, of course, there are many of them, and they can fit your needs or your affinities. And again, if you're already using a configuration management tool for your infrastructure, try the modules that exist for it to deploy Ceph, or try another solution. So you have them in one place. Where do you go from there? You want to run them regularly. If you use Puppet, it's kind of built in Puppet. So every day a Puppet will run and check if your cluster is configured correctly. But that's not the case with Ceph Ansible, for instance. You just run Ceph Ansible. It creates you a nice cluster, and then well, you should run it like once a week for two reasons. One is to correct some manual changes that could last on your cluster. For instance, you want to debug an OSD or a service, so you up the log level and forget to put it back down to after you corrected, you fix your bugs, and it stays on like that, sending lots of logs unnecessarily. And the other reason is to build confidence. If you have your tool that runs regularly, when you have to push a change, like a few months later, you won't be wondering, I didn't run it for a few months. Will it break my cluster? Will it break something in it? I don't know. I'm not sure. So if you run it regularly, you have the confidence that the change will be applied correctly and without consequences. So I use a configuration management tool. You have all your config in one place, centralized on the server. So why not try GitOps? GitOps is a methodology where operators or administrators use Git repositories as a way to store and update their configurations. So it allows you to roll back version, comment, and much more your configuration of your Ceph cluster. If you use a configuration management tool, most of them use text files, so it's perfect for this purpose. And the next step after GitOps is maybe going to CI/CD. You have everything. You had everything on the server. Now you have everything on a Git repo. You can build pipelines to test your change. So build a pipeline, push a change to your dev branch, apply it automatically via the pipeline to your test cluster, and then based on the output of the pipeline, you can choose to launch the pipeline to deploy it on your Ceph cluster, the pipeline or your deployment job. All right, next topic, updates. That's a big topic, and it's a really important one. There used to be a saying back in the day that said, yeah, if it works, yeah, don't upgrade, don't need the trouble. And the thing is, nowadays we push a lot of changes. There are people that put in, things into production multiple times a day, so you should look into it. Why should you update? If you update, if you push a change, it's most of the time to make things better. Their changes have a purpose. There has been these many changes from the stable release of Mimic to the stable release of Nautilus. And there has been these many changes, commits, from the stable release of Luminous to the latest 0.12 release. So that's a lot of change. They're coming fast, but they're good. If it works, okay, but it can work better. Just an example, we upgraded one of our cluster from Joule to Luminous, and this is a write workload. This is a kind of special workload. It's a cache flushing workload. We have a batch of jobs that write to a cache tier in front of an EC pool, and at some point when the job are finished, the cache pool is flushed to the EC pool. So that's typically that kind of job. Just upgrading from Joule to Luminous, we nearly doubled our write throughput on the job. Just simple upgrade. And then, of course, we made the change to from FileStore to bluestore, and that happened. So, upgrade. Upgrade, but do it carefully. There are things to consider, of course. Release notes are your go-to reference. I feel dumb saying that, but it's really important. They list new features, of course, but also bug fixes, new change, behavior change. There are changes in behavior because every product evolves. So there have been changes in maybe the output of self-health that might affect the way you use your cluster, your monitoring tools, stuff like that. So read them carefully. And beside the release notes, there are update notes. And the update notes, you want to follow them really carefully too. Because down to the last line, every option, every flag is important. To give you an example, when we upgraded our previous cluster to Luminous, a few days later, we had an issue where OSD started flapping. We didn't notice for a few hours, and when we realized it, it was too late. The OSD would come back up a few times and then create a lot of PG map changes, and when the OSD would come back up, they couldn't cope with the number of changes, so they started eating all the RAM on the servers, and OM would come, kill them, and then they would start again, and so on and so on. We spent a few days, 2 days at least, fixing the cluster, and we realized in Luminous there was this new feature that trims and limits the PG logs on the OSDs. So I said, wait, but we're in Luminous, it should work. And we realized we forgot the last option. It's among the last lines of the update notes that says, Ceph OSD require OSD release Luminous. And only by activating this flag, you activate the Luminous fixture on your OSDs. So if we didn't overlook that small flag, we wouldn't have a problem. So yeah, furthermore, tests. Don't rush to put the latest release on your production cluster with petabytes of critical data. Test it and share your experience. You can share it on the mailing list. You can share it on the bug tracker if you find some bug of bad behavior. Just say, yeah, we upgraded a week ago. It went fine. No issue. No issue up to now. You can go ahead. All right. Our next topic is maintenance in cluster life. These are statements and behavior, statements and tips, sorry, on what to do and how to envision the life of your cluster. The first statement is disk will fail. They will. It may be days after being put into production. It may be years after being put into production. And if it's days after being put into production, most of the time it means bad batch. So if it's bad batch, you may have multiple OSD failing during a short period of time. So either the drive dies directly, or maybe errors during scrub. And if you have multiple scrub errors or multiple inconsistent PGs after scrubbing, you may want to look to the common OSD, because most of the time there will be a common OSD involved in the PGs. So that's the first clue to say, yeah, the OSD might go bad. So you want to assert that with a smart check. It's the easiest thing to do. Run a long background check. It takes a few hours. Let it run. And maybe in the end, you will have, the test will fail, and you will have uncorrected errors during the test. And that means the disk is bad. So if your disk is bad, you want to replace it. There are multiple ways to replace it. There are good procedures in the documentation, but replacing a disk is often a topic we see on the mailing list. What you want to do when replacing a disk is avoid unneeded rebalances of your data. This is the most common way to replace an OSD. It involves two data rebalance. And it assumes on some part that your OSD is still up, but even if it's down, it works. So first you want to set the crush weight to 0. That way it will drain the data from the disk and avoid rebalances after remapping. Then you want to set the OSD out. Then the cluster will know that the OSD won't ever come back. Remove it from clutch map and the cluster. You replace your disk and use your configuration management tool to build your new OSD. This is the safest way to go, because if you don't have a disk handy really immediately available to replace, after the rebalance of the crush map change, after you set the crush weight of your disk to 0, your cluster will be else okay, because all data will be okay on a radiant density level. There's another way for replacing a disk, and this way involves a single rebalance of the data. Actually, it's not rebalance, it's a backfill. It's just some kind of in-place replacement of the OSD. So you set your cluster to no out. So you tell the cluster not to mark the OSD out. You remove the OSD not from the clutch map, but only from the cluster itself. You replace the disk, rebuild it using your configuration management tool. The OSD needs to have the ID of the old OSD. The new OSD needs to have the ID of the old OSD for that to work. And then when you start the OSD, it will just backfill the data it had previously. So single replacement disk, but until you replace the disk, your cluster is still in a bad state, and you can have lost a bit of redundancy. Next topic, next statement, PGs are your most important resource. We talked a lot about OSDs, we talked about objects, but PGs are really the unit Ceph uses to manage, place, recover your data. So that's the thing you should look about. The norm is to put around 100 PGs per OSD. If you have less than 100 PGs per OSD, you have risk of imbalance. You can end up with OSDs being 80% full, while other will be only 30% full. If you have more than 100 PGs per OSD, this will overstress the cluster in bad times, in times of recovery, because the cluster will have to accommodate with a lot more PGs. The OSDs will have to accommodate with a lot more PGs to remap, to rebalance, recover, and you will consume much more CPU and RAM, while it's not really needed. So when you create a pool, plan carefully. Once again, there's a great tool called pgcalc on the Ceph.com website. You can build your pool structure, and it calculates for the number of PGs you need for you. Of course, with Nautilus and the new auto-tuning and PG decrease feature, it's not as important, but still most of them are not in Nautilus yet. So my advice when creating PGs and creating pools is start low and increment later. Imagine you have a new petabyte cluster. You say, yeah, I'm going to only have one application that will use the cluster. So I create a pool with the number of PGs for the whole cluster. And then a few months or a year later, there's another team that comes to you saying, yeah, but we have another application. So you want to create a new pool or maybe try eraser coding or stuff like that. And you realize that, oh, but I set the number of PGs to accommodate for the whole cluster. So if I add a new pool, I will have a lot more than 100 PGs per OSD. So start a bit lower on the number of PGs that may be recommended, and then increase a bit later. So you will avoid, better have a bit of imbalance that you can easily correct than overstress your cluster in case of recovery or in bad times. And last thing about PGs is you need to understand the states of the PGs. As I said, it's the most important thing in Ceph, it's PGs. So you need to understand what are the consequences of having PG active, not clean, and various unclean states you can have. It will help you a lot during troubleshooting times. Okay, last statement. Scrubs are your data best friend, but they can also be your worst nightmare. Scrubs are essential to data integrity of your cluster. Scrubbing is the process where Ceph will read all the replicas of an object to see if there are any corrupt ones and warn you about with inconsistent PGs and scrub errors. With the release of bluestore, there has been this new feature called checksums. And people started wondering, if I have checksums, do I still need scrubs? And the answer is yes, because checksums only checks data when the data is read. And scrubbing checks all the data on your cluster. So even the little ones. So you won't end up a year or months later trying to access an object and find out that the replicas are corrupt because of bitrot, bad disk, cosmic rays, whatnot. Scrubbing is important, but it's also quite hard on your Ceph cluster because in its nature it reads all the data of your cluster. So while it does that, it can impact your client's operations. So you want to tune your scrub configuration to make it less impactful on your cluster. These are the most common options. to configure scrubbing. You can set a scrub window. So scrubs will only happen a few hours a day. You want to set that to off-peak hours, obviously. OSD scrub sleep is another popular option. Basically, it tells Ceph to wait between scrubbing a bunch of objects. So it will scrub a bunch of objects, wait a bit to let client operation use the full resources of the cluster for a small amount of time, and then move on to scrub the next bunch of objects. If you use a scrub window, you might want to tune your scrub interval. By default, it's 1 week, so PGs are deep scrubbed every week. But if you put on a scrub window, it will be maybe it will not be enough. So you may want to scrub them every 2 weeks, every 3 weeks, but don't put an interval like 6 months. It's a bit crazy and it's dangerous for your data. If you tune the window and the interval, you might want to also tune max interval. So this is the amount of time after which Ceph will deep scrub your PGs anyway. So you can end up with PGs scrubbing outside of your defined scrub window, which can impact your performances. All right, these were 3 statements, and these were really basics one. I didn't even talk about CephFS, Rails Gateway, RBD client options, stuff like that. The thing is, Ceph is hard. Well, it used to be hard because of all these options and because you have access to every bit of the system, which most of the time you don't need to, but you still have to know the intricacies of the system. But of course, it's a storage system and it's a distributed system, so it will be complicated. But the future is bright. We talked a lot about that during the keynotes, notably Ceph and Gerald. There are lots of new features that have come into play during the last releases that will really help you manage your cluster more easily. So there's the Balancer Manager module. It balances the PGs on your OSDs to make sure the usage of OSD is properly balanced. It does that automatically. Orchestrator module, of course, we talk about it. Interface for the configuration management tools to deploy and operate your cluster. The dashboard is a great feature, and in Nautilus, you can now do actions like creating pools, provisioning RBD images. So it's really eases the introduction of new member on the storage team to use your Ceph cluster. PG decrease and automatic tuning. I talked about that earlier. Disk failure prediction. So you can know ahead of time which disk will fail. And centralized configuration in monitors, so you avoid having tons of ceph.conf files across your nodes. And that's it. Thank you very much for your attention. If you have any questions, I'll be happy to answer them.